Hello. Be sure you grab 8.4 Day 1's notes at the top of the room by the smartboard. So if you have not grabbed your notes packet, please grab it as soon as possible. Substitute, I ask to pause quite often. So first off, let's make sure everybody writes down evaluate logarithmic functions. And then I want you to see if you can figure out the value of x in each one of these spots. See if you can find the value of x in each one of these spots. Before we pause here, just want to make a couple announcements. We will go over quizzes tomorrow. We will also review the participation on the calculator park practice tomorrow. I just wanted guesses. I had a couple people wonder, hey, did I get the right answer or not? Not looking for right or wrong answers, looking for attempt. So try the best you can, but you've got to have an attempt down. So substitute if you could pause so people can attempt these. Looking at the answers. 3 to what power gets us 9? That power has to be 2. What to the third power gets you -8? That has to be -2. We actually learned how to undo a cubed power last chapter, where you take the cubed root of both sides. We haven't learned yet how to figure out an exponent. Anything to a 0 power is 1. So in this case, the x spot is 1. 10 to what power gets us 0.001? And it's actually 10 to the -3rd power gets us that. This is something we'll learn today, how to figure out how do we undo this. Or my bad, we'll be figuring this out next week. Anyway, 3/2 to the -1 power. Wait a second. This means we got to flip it. So x is actually 2/3. Be sure you wrote down evaluate logarithmic functions. That's the objective for today, using our logarithmic function on our calculator. So the challenge today is trying to figure out where's your log calculator button. At the bottom, or sorry, not at the bottom of your notes, but all of a sudden you see this question and it says, for what value of x does 2 to the x equal 6? And sometimes these powers aren't so easy to figure out. Like 3 squared equals 9, but what if I wanted 3 to what power gets you 6? 2 to what power gets us 6? There's not a perfect integer, because 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. Oops, skipped 6. So this is where logarithms come into play. Logarithms actually undo a missing exponent. They undo a base, I should say. Logarithms undo bases. Roots undo exponents. Logarithms undo bases, and that's where we'll get to this week. All right, so definition of logarithm with base b. First off, let b and y be positive numbers. B is not 1, so this base that we talk of is not 1. Logarithm of y with base b looks like this. Logarithm of y with base b. Sometimes you'll hear me say log base b of y equals x. And it's defined as the following. So log base b of y equals x if and only if b to the x equals y. Let's pause a moment so we can get this down. We're also going to stress how we say it. So below here, I want us to write down the quote, because you're going to hear me say it a lot, and I'm going to stress language. Log base b of y. This is called logarithmic form. And then this piece over here is called exponential form. Sorry if you heard the bell on my iPad. There's a sort of circular, I don't know, motion with these. If you're going from one form to the other. So if I'm going from logarithmic to exponential, I'm going to write base b to the x equals y. See the circular motion, how I'm going base b to the x equals y. And if you go the opposite way, you still do, so you're going to, but you start by saying log. You say log, and then you start saying, okay, base b of y equals x. So it's a circular motion whenever we go from one form to the other. You're going to hear me call this the circle of life. We're going to keep practicing it. All right, so if students need this to pause, please pause. On to the first example. So log base 3 of 9 is 2. We're going to rewrite this we're going to write it in exponential form. So just to practice, I'm going to put it up. Log base b of y equals x can be written as, and I'm going to put double arrows because it can go back and forth. So the circular motion, base b to the x equals y. Base b to the x equals y. So log base 3 of 9 will be rewritten as base 3 to the second power equals 9. And notice how this makes sense to us, like 3 squared is 9. Okay, so we're practicing trying to figure out from one form to the other. Next one, we're going to do base 8 to the 0 power equals 1. So we get the form 8 to the 0 power is 1. Last example, log base 5 of 1/25 equals -2. We're going to take base 5 to the negative second power, and that's going to equal 1/25. And wait a second, does that make sense? 5 to the negative second power, well, 5 squared is 25, and that negative gives us a reciprocal. So this is the other form. All right, next examples. Oh, my bad. Special logarithm values. First off, whenever we have the logarithm of 1, so log of any base of 1 is always 0. And it's because of this, well, let's see what it looks like in the other form. So because, and let's actually write this off to the side in our notes. It's because if you take base b to the 0 power, it actually is 1. Anything to the 0 power is 1. And then let's look at the next one. Well, if we wrote this in the other form, base b to the first power is b. So if you had like 5 to the first power, it's going to be equal to 5. This will be quite useful when we graph, like our nice numbers that I talk about plugging in. These properties will help us when we graph. So let's see some examples. So here we go. First example, log base 4 of 64. What we're going to want to do is we're going to want to get this argument, these arguments in terms of, we want to get these arguments maybe in terms of the base. That'll be our ending goal. Before we get there, let's actually say these are equal to x. We're going to set every single one of these equal to x. And we're going to ask ourselves, okay, let's rewrite it in the other form. 4 to what power equals 64? Because wait a second, we can take 4 times 4 times 4, get 64. So in this case, x is 3. In example 5, if we move things around, 2 to what power equals 0.125. Let's think about this. Wait a second. 0.125. Let's get that as a fraction. Should be 1/8. So 2 to what power gets us 1/8? Wait a second. It's a fraction, so it's probably going to be a negative power. So 2 to what power gets us 1/8. 2 to the negative third power would get us to 1/8. So in this case, x is -3. You should at least be able to say, okay, 2 to the third power gets me 8, and then the reciprocal needs a negative exponent. In the last example, 1/4 to what power gets us 256? This one's a little hard. What we're going to need to do is get these in the same base. Can 256 be written as 4 is the question, or can both of these be broken down into the same prime? 4 can be broken down into 2's, and 256, so we're looking at 2 to, I guess, the 8th. My factor tree looks a little crazy here. So here's what I'm going to write. Instead of 1/4, wait a second, 1/4 can be rewritten as, well, 2 to a -2 power, because it's a fraction raised to the x. And that's going to equal 2 to the 8th power. So wait a second, -2 to a power x? If I have an exponent raised to an exponent, I'm going to multiply those exponents. So 2 to the -2x equals 2 to the 8th. The only way these two things can be equal is if x is a -4. So my apologies for running out of room, but x is going to be -4. We've got to use some reasoning. If you did not see that, we had to see -2x had to equal 8 somehow, and divide both sides by -2. That's where we get -4. Please pause if they have questions or need it to slow down. So let's talk a little bit about common logarithm, because we had, well, never mind. Common logarithm is a logarithm of base 10. Typically, well, sometimes we might see log base 10, or we might not even see a base at all, and we're just going to assume it's log base 10, because we're in the base 10 system. But then we also need to stress the natural logarithm, a logarithm with base e. You could either denote it as log base e, or this ln, which you actually have a special button on your calculator for ln, and it stands for natural logarithm. It's a logarithm with base e that we talked about last week, that e number. And actually, check out your calculator. You should have a log button and a natural log button. So let's practice using our calculators. I encourage students to help each other with finding buttons on your calculator. Please pause after each example to make sure you are getting these. So log 7, you're looking for your common log button. It should actually look like this. And then you press 7 and your equal sign. You should be getting approximately 0.845. So please pause, make sure students are getting that answer. And let's, first off, notice how directions here are evaluate. So I'm looking for a value. If it said simplify, not looking for decimals. But evaluate, yeah, we're going to use decimals. And let's just go with a general rule of 3. Let's go to 3 decimals. So in the next example, look for your natural log button. It actually looks like ln, and you're going to put in 0.25. Then your equals button. And, ooh, if you have a green calculator, you know what I mean by whenever I say green calculators. You may have to go in reverse order, where you have to put in your argument first, 0.25, and then hit your natural log button. You won't even have to hit the equal sign. These steps are for blue calculators and the like only. So be aware of that. If you're not getting the right answers, you might have to be a backwards kind of person. So you have to put 0.25 and then hit your natural log. You have to hit 7 and then hit your log. But we should be getting -1.386 in this example. So please pause, make sure students are getting it. So inverses. How do we undo things? The inverse of an exponential function is this log function. So this means the following. The composition g of f of x, this is going to equal, okay, wait a second. f's function is b to the x. I'm going to plug b to the x into the x position in g. So it's no longer going to be x here, it's going to be b to the x. It looks like the following. Log base b of b to the x, which, wait a second, one of our properties say log base b of b. These guys undo each other. That equals 1. So we're left with x. And we also can go the other way. F of g of x, where we're going to put g of x and replace this x. So it's going to be b to the log base b of x. And what I'm telling you is these guys undo each other. B to the log base b power just leaves you with whatever that argument is. We're going to use these properties where if you see log base b of b to a power, we're going to use this undoing aspect when we simplify. So the next couple examples, my bad, we already wrote that down. The next couple examples, we're going to simplify. So no decimals. We're looking for, how do we simplify? So in 10 to the log 10, in 10 to the log x, hold on, common log here. Common log has a base 10. I'm going to actually write that. This is 10 to log base 10. If I don't see a base written, I assume it's 10. And in this case, 10 to the log base 10 undo each other, and I'm left with x. So in the next example, log base 5 of 125 to the x, wait a second, if I want to use this property, I have to have the same base. How can I get 125 to be written as a 5 somehow? So let's do a little factor tree. So we're going to have log base 5, and instead of 125, I'm going to write 5 cubed to the x. Let's do a little exponential property, or exponent property. When you have 3 or 5 cubed raised to the x power, that turns into 5 to the 3x power. Now I see log base 5 of 5 undo each other, and I'm left with 3x. Please pause so they can get this down. Finding the inverse. So let's practice finding the inverse the way we did in chapter 7. Finding the inverse the way we did in chapter 7. We switch x and y first. Then we solve for y. Well, in order to get y by itself, we're going to need to rewrite in the exponential form. So wait a second. Notice how log is on this side. So our circle kind of goes backwards. We're going to do 8 to the x equals y. 8 to the x equals y. This is our inverse. So let's actually put that down. F inverse is 8 to the x. Because if I call it y again, wait a second, y is equal to 2 different things. That might be a little confusing. So we'll say F inverse of x is equal to 8 to the x. Similarly, in this example, let's write natural log using log base e. So not only am I going to switch x and y immediately, I'm also going to rewrite natural log as log base e. So notice what I did. Switched x and y, and instead of natural log, log base e. We're going to do the circle again, but it's going to be backwards because my log's written on the right side. So e to the x equals y minus 3. Wait a second, I'm supposed to get y by itself. In order to do that, we're going to add 3 on both sides. So technically my inverse is e to the x plus 3. So please pause so they can get this down. And tonight's homework, I want you to do 16 through 34 even. Most of this is rewrite in the other form. Can you go from logarithmic form to exponential or vice versa? And then these last few, can you simplify using that new property? New property of, okay, log base b of b to a power just spits out that power. These guys undo each other. You're looking for that. Please message me on Remind if you have questions. Thank you.